Coming next for the basic window functions. So window functions are the symmetric window functions. Now these are used in FIR filter design to guarantee the linear phase response and primarily to truncate the infinitely long impulse response HDN. As we seen, the result of the convolution, there appears the ripples in passband and the stopband. If this window function are a smoother functions, as in the different cosine type of functions instead of rectangular window function, then the truncation will be occurring more gently instead of an abrupt truncation. We will look at this point during the Gibbs phenomena also. So in the slide, you could see the four different window functions as rectangular, Hanning, Hamming, and Blackman window. And these are typically the frequency domain characteristics or the spectrums of the window functions. And for these spectrums, we are primarily concerned about the two parameters, that is the main lobe and the side lobes. So again, these plots, they are the indicators of the shape of different window functions. A rectangular window function is a box function, a box type of function, and followed by that there are Hamming, Hanning, Blackman, and Bartlett functions in the time domain. So these all are the time domain plots. M by 2 is the center of symmetry for the window function, since window functions are also symmetric functions. And in the next plot, we see the spectral characteristics of the window functions. In the spectral characteristics, the rectangular is having the narrowest main lobe width, and as a result, the transition width is optimized. The transition width will be least in comparison to other window functions. The table provides the important parameters with respect to 4 to 5 different window functions. As in, for the rectangular window function, the peak side lobe, that is the first side lobe, its amplitude, its relative side lobe amplitude is minus 13 dB, which is counted from the peak value, that is 0. For triangular window, it is at 25 dBs, below 0 dB. For Hanning window, it is minus 31 dBs. Hamming window, it is minus 41 dBs, and for Blackman window, it is minus 57 dBs. It means the Blackman window will provide maximum attenuation, but as a contrast, we have to tolerate the main lobe wider width of the Blackman window. So again, these are the time domain and spectral characteristics for this window functions. What we are practically also generating to understand the nature of the window functions in time domain and frequency domain. So two important desirable features of any window function is the main lobe width should be narrow. So this is what is the main lobe width. In the previous slides, you have seen only the positive side of the frequencies. There is only half of the part of the spectral characteristics of window. In this plot, it shows a complete picture of the spectral characteristics of any window function. For all type of window functions, they will either be a sink or sink-like functions. And in the sink or sink-like functions, two primary parameters we are looking at, that is the main lobe and the peak side lobe. So out of that, it is desired that main lobe width should be as narrow as possible. In turn, the transition width of the filter response will become narrow. Similarly, the side lobe amplitude should be smaller in height so that it will provide the maximum attenuation. So these are the mathematical expressions for the Hanning window, Hamming window, and the Blackman window. A rectangular window we have already seen. So these are also called as a raised cosine because all of them they contain the cost terms over there. More number of cost terms indicates more gentle will be the truncation of HDN by that respective window function. So this window function mathematical expressions are when the range of small n is from 0 to n or 0 to the finite length, and wherein this description is for minus m up to plus m, that is symmetry point will be at 0. So accordingly herewith there is a positive sign and herewith there is a negative sign. Now we will follow one common practice which the table is provided later. Now out of all the window function, none of the window function at one time is satisfying both for main lobe and side lobe. That is, main lobe should be narrow, side lobe height should be smaller. So there is one such window which is also called as the best or the optimum window function, that is the Kaiser window function. The important characteristics of Kaiser window filter is it has two controllable parameters, that is alpha and beta. So with the help of this alpha and beta, and IO of this function is called as the zeroth order Bessel function. And these are the characteristics in time domain and spectral domain for the Kaiser window. So with the help of this controllable parameter, we can try to obtain the narrow main lobe width and a lower or the smaller side lobe at a time in most of the cases by means of Kaiser window function. This is not the case for any other window function. Either in other window functions, either we will get a narrow main lobe width or we will get the smaller side lobe width. So herewith is the summary of the window functions which we will be making use for designing the FIR filter, that is rectangular window, triangular window, Hanning, Hamming and Blackman window. These all are the time domain plots of these window functions. In the second column, it provides the mathematical description of these window functions for the range of small n from minus n minus 1 by 2 to plus n minus 1 by 2. Then in the next column, it provides the frequency response plot for all these window functions. In the next column is the main lobe width, which is the function of length of filter and which is fixed for each filter, each window type. That is, for the rectangular window, the main lobe width always be equal to 4 pi by capital N. For triangular window, it will be 8 pi by n. Hanning Hamming also will have a main lobe width as 8 pi by n. But for Blackman window, it is 12 pi by n. That is, it is wider in case of Blackman window. And in the next column is the peak side lobe amplitude in terms of an dB, that is an attenuation, as each of the window function provides. At the end of this session, try to answer these review questions. Explain the procedure of designing FIR filter using Windows. What is meant by a Gibbs phenomena and how to reduce it? Compare different window functions. What are the desirable features of window function? And which is the best window function and why?